Totally amazing here. The home of scientific knowledge, discovery, truth, research, and of course, reverse engineering. Since the 1st of January 2K19. Now, we have here the MAKITA cordless impact wrench, which you saw in a previous episode. Now, we're going to be doing some reverse engineering on this, all right? But before we actually do that, we need to examine what reverse engineering is, who does it, why is it done, and how is it done, all right? Well, what is reverse engineering? Reverse engineering is basically the whole basis of taking something apart, like our example here, to find out how it works. And that could be done for any number of purposes. And generally this now means that we can move on to who does it. Well, there are a number of people that do reverse engineering. Number one is people like, don't want that falling over, Area 51 and people like myself. Yeah, kind of alien technology, crash sites or whatever, UFO crash sites. And of course, equipment like this, that generally doesn't come with build plans and the originators aren't going to give you them. Alien crash sites in Area 51, yes, if there's been a UFO come down, you better believe it. There's going to be entire governments and people that are dedicated for this thing. Military technology. You better believe it, yet again, there are an entire government. In fact, every government in the world would have entire departments and entire complexes dedicated for this. If you had something like a stealth fighter jet come down in enemy territory, you better believe it that that territory, their military are going to be hot on that, dismantling that equipment to find out how it works. This is usually done for obviously counter operations and to see if obviously the opposition can advance themselves in some way. Okay. Now the other reason for reverse engineering is again, it could be that MAKITA here don't want to provide me with their stripped down guides. It could well be. Quite why they wouldn't, I don't know. I mean, I have asked, I've sent numerous emails. Whether or not they were read, or whether they were just spammed off, I don't know. Whether or not they ignored it, whatever happened, I don't know. But suffice to say, I've been waiting about 2 weeks or so. I do apologise for the coughing. Asthma's quite bad today. But anyway, suffice to say, I've been waiting for drawing plans of this. Nada, not a bean. Now, I could, I suppose, if I really wanted to, go out there and Google the battery part name or part number of that battery and have a look and see if there's anything that matches that. But if you watch my episode on what's in my handbag, which isn't really a handbag at all, you'll see that these batteries are interchangeable with other devices. So I'm not really going to get much luck there. So this brings us down to another reason for reverse engineering. If we can't find design plans for this, we are going to actually take down this device and do a teardown and make those plans. Now, I'm probably not going to make it available. I shouldn't really need to because you have a video here to refer to. But that's the point. Now, again, there's one other set of people that will do this, and that's for commercial reasons, for workshop guides. If you own a car, any popular make of car, you would have probably heard of a company called Haynes. Now, they actually manufacture workshop manuals. And those are geared for taking down components out of cars, doing full teardowns and rebuilds. Because obviously manufacturers of the vehicle will not, cannot, for whatever reason, provide those drawings. Or generally speaking, they just don't want to, for obvious reasons. So then we need to look at why, well, not why, but how to get this stuff. So that's what reverse engineering is. It's taking something apart to find out how it works. Then we can either make the necessary repairs or improve the design. That's what it's about. Reverse engineering is exactly that. It's the art of dismantling something to find out essentially how it works. So that's what it is. And we're going to be using this MAKITA as our cordless impact wrench here as our example. Now, for this, yes, we'll need a brush. I don't quite know why I'm waving that around, but anyway, we will need one of those. We're going to need a selection of fastener drivers, and I have more should I require that. We'll also be needing tweezers. I probably ought to be wearing some sort of nitrile gloves, but I'm not really too worried. Then we'll need some coloured pens. I'll explain why in a moment. Along with some sellotape, some various coloured A4 paper, a clipboard, a couple of other marker pens, and of course a regular ballpoint pen. So we have our MAKITA impact wrench here. Let's zoom in and let's look at this a little bit more in depth, and you'll see where I'm going with this. The reason for the clipboard is going to come apparent as well. Ah, I see. You're probably getting the point of this now as soon as I've done that. Right, now I need something to point with, just to explain what's going on. Now this isn't the best drawing in the world, and it's certainly not to scale, but it will give you an idea of what we're doing. All here, 1, 2, 3, 4, 5, 6, 7 and 8. In orange, that's the takedown order for which we're going to dismantle our cordless wrench. Then on the back, where we have rear view, there's 2 more fasteners here. As you can see, there's the 8 on the side. 1, 2, 3, 4, 5, 6, 7 and 8. Which are represented here on the orange dots, and they're numbered. Then we have a PH2 that's written here with a cross, because those are Phillips, or just better check they are Phillips and not Puzzies actually. I might have actually even written that wrong, I hope not. No, they are Phillips. Phillips 2s I do believe on those. That might be questionable. We'll have to double check that in a moment, but if we need to, we can always change that writing there. So that's just giving us a sort of key as to what these actually are. So what we do is we undo our fasteners, and then each one we remove gets stuck using sticky tape. Each screw or each fastener is then stuck to its corresponding number. I'll show you how this works in just a moment. And we'll stick the fasteners to the paper using sticky tape. Once we've done all of that, we can then take a second piece of paper and then write down dismantle 2, draw out the layout of that, of what it looks like inside, and then we can use our clipboard, clip that to it, and then remove the next load of fasteners and stick that on there as well until we get to what we want. Okay, Okay, right, so let's just begin and get that done. So I'm going to start by taking our clipboard and just move that slightly out of the way so we can see exactly what is going on there. So let's just back out. And I know you might not necessarily be able to see how I'm removing things, but that's fine. So we said that it's pH 2, so I think that might be slightly wrong. I didn't actually double check that. I'm going to start by checking something slightly different. And what's this driver? Well, that's a PZ1 on there, so let's check it with that. It's not a PZ1, so we're okay there. I think it is a Philips. That's a PH1, sort of. No, that's not doing anything. Quite sure what's... Oh, maybe it is a Philips 2. It just seemed a bit wrong, that's all. But this is the beauty about reverse engineering in this way, because then we can actually... that's the PZ2. It's not going to be that anyway. So, but this is the beauty of this. Basically, we can do our teardowns properly, and we can make the necessary adjustments on the paper as we go if we have to. So let's start by trying. It is. Okay. Thought that might have been slightly odd. So now we can start the teardown process. And as you see, now that I've removed the first screw, what we need to do, or fastener, we need to do, take some tape, that bit, stick our tape over our fastener, and stick that straight to that paper. Happy with that? Easy. And now nothing gets lost. That's stuck on there, and now we have our own reference guide as well. And then when it comes to rebuilding, we just follow from the numbers back. It's like painting by numbers. It really is. Only instead of painting, we're doing teardowns. So, what we can do here, let's just move this over here. And now what we can do is sort of zoom in a bit more. And there you go. I might have to zoom out a bit more. That looks okay there actually. I can still see what I'm doing. I mean, if I really want, I can just take, let's just remove the, oh, knocking everything over. Let's just take some card. Just tore off the back of that thing anyway. So it just gives us something to see a bit better with. So we'll just go ahead and start moving that. So number 2 is now to be removed. There we go. That's fastener number 2. As you can see there. So we'll just take our cello tape. Stick that. That's not really stuck down very well. That's a rubbish bit of tape. Let's try it again. This sellotape's not very good. I actually do have some better stuff than this, but I can't be bothered to go and get it. I probably ought to have. It's not going to stick down now, is it? The first one did. There we go. I'll probably just double tape over that anyway. In fact, the almost spent roll was actually a bit better. I'll just double tape over that just so we know it's not, that screw's not going to come out and get lost. And we'll double tape over that one too. And we just essentially keep doing this. That's all we need to do. So the third one out. We could... Alright, so we do end up needing tweezers then. This is always essential when it comes to reverse engineering. And the third one out. Hopefully I don't get into trouble from this from MAKITA. I don't think I would do. But I don't think they would really want me, you never know. They might not like the idea of that, but that's just their problem really. Now we do number 4, which is here. Oh, this is easy, isn't it? I probably ought to remove the ones from the rear motor cover first, but I guess we'll find out just whether or not I've done anything right. And again, this is the beauty of reverse engineering. This is why we do things this way. So then we can actually retrace if we've done anything wrong and correct it. And you better believe it, that as I said, there are indeed entire government departments that actually specialise with this. There we go. And we can see clearly as well the order that we've done. Okay, a few of these I've gone over I can just sort of move the fasteners away from those numbers. So that's why we use the clear tape, so we can still see the numbers there as well. Now again, sort of a decluttered working area is always essential when you're doing this, and always try to keep the job in that specific location. This one's a bit trickier. Now the other thing is, you see also, look at this. The fastener heads now, and the well, not the heads, but, well, yeah, the actual heads and the length of the threads and the width of the threads are different. This is another reason why we do this. So we actually have the correct order. Goodness, innit? And then you also don't lose any of the fasteners either. At least if things are done correctly. There we go. Sticking that down and then making sure that none of these can get lost. You just have to run another load of tape over that. They're not going anywhere. Now we remove fastener number 6. Oh, that one is a bit trickier. Now that's the other thing as well. Alright, you see with these threads, if they do become damaged for any reason, now, because I actually know where it comes from, I can go off and find a fastener of the sort of same... Let's just move all that out of the way. I can now go off and find a fastener of the same specifications as that and replace it. So this is why we do these things. And now we also know exactly what type it is. So if I wanted to now, what I can also do is measure each one and be very specific about that, and then start to create my own workshop manual for this. And this is essentially how this is done. Yeah. So that's number 7. Just try not to use that. And there you are. We've got it all stuck down there neatly. And then you'll see what we do once we've removed the other fasteners. So there's just 3 to remove. This is a sort of long-winded process, but it's really the only process that we do have as we don't actually have the stripped down guides for this. Well, that's going to be awkward because our driver doesn't appear long enough to go down in there. Okay, so I'll need to go and find a different driver or something that's equivalent to remove that thread. Don't think it's going to be one of those. Right, I'll just have to keep searching. That might be a problem, because I might not actually have another driver. That could be sadness. Let's try this. Is it sadness? Is it? I think that might be some sadness. That. Let's just have a quick look under that lamp. That could be sadness. That's not good. So that's only one of these fit. See, what we can also do is test against the fastener heads, which driver would be better for this. This could be a problem. It could very well be. Okay. I can't get that last one out. And I don't know if I've got any. No, that's not going to. Ooh, this could be rather interesting. That's not, that's too big. Could it be that? Gosh, that's not recommended because it's a flathead, but it might be all we have. Ah, there we go. Ah, perfect. Not recommended to use a flathead on Phillips, but if you're careful, you can. You should be able to now try and lift that out. Right, turn it upside down carefully. Ugh, some sorts of dust coming out of that. That's good, isn't it? Let's just get that stuck down first, and then we can write down a slight amendment on that for number 8. Let's just you stuck down. There we are. You're not going anywhere rather. And now that's a slot 3.5. So now we take a pen here and then write down here number 8, slot head 3.5 millimeter. Do that. Initial untighten and for fitting final tighten. And there we go. And then you should end up with something where that looks like that. Now all we need to do is just remove the fasteners on the rear. Let's try that, hopefully, in this video. Yeah, beep, 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 whatever's going on out there. Maybe that... Yeah, I'm not sure what's going on out there. Beep, beep. Beep. if you can hear that anyway, I'm not just making big random beeping noises for no reason. There's cars outside. I wonder if we should reverse engineer them. Not the cars, the drivers. I'm not sure we'll find much though. I don't know why people have a need to do that, but I actually stuck that in the wrong place, but I might have to double check that. Hopefully these fasteners are the right, well, the same size. They look it. I got the hassle of removing that. And yeah, they're the same anyway, so that's okay. Alright. Stuck there. You see, this is how things actually should be when, you know, like when you get flat pack furniture. It'd be a lot bloody easier if they actually did this, wouldn't it? You know, with the assembly guide. But there you are, that's all the fasteners stuck there. And then towards the end of an evening, if we wanted to stop for any reason, we can just do that, leave the job there, and then we can come back to that in a moment. So that's what we're going to do. Alright, that's part 1 of this. So join us in part 2 when you actually see us strip this down even further. I'm going to carry on off camera now and just do the next level of preparation. So join us in part 2 when we open up another page and we essentially do the same thing again. So I'm going to see you in part 2, dear lovely viewer. Oh, and there is one thing other actually. I've had a bit more of a shakedown on this workbench, so as always, look, there it was. Like, comment, subscribe, and get that bell on. See you in part 2. See you soon.